And sometimes it's really hard to memorize all these different rules. They get jumbled up in your head. So I'm going to show you a way, like if you forget the rule, how can I write this out for repeated multiplication? X 5 times X 3 times is how many X's? Count them up. How many X's are being multiplied together? 8. So I could write this as X to the 8th power. What did I just do to my exponents? How? What's the rule? Add them together. If you have the same base, you can add your two exponents together. Add. That seems pretty easy in and of itself, but then you're going to have like 5 other rules to like get jumbled in your head. So if you ever forget, write it out for yourself and then count them up so that you know you have the right answer. The quotient rule is, if I wrote this out with repeated multiplication, I have x to the 4th over x cubed. So what can cancel? 3 of those cancel. And remember from our test, some of you thought 0 was in the denominator. There's really a 1. Anything divided by itself is 1. So I really have x to the 1st power. What do I do to the 4 and 3? I could just write or just x. But what did I just do? I canceled. So instead of n plus m, it's n minus m. So it's subtraction. So kind of the shortcut is to subtract, but if you forget, write them out and cancel them. And I think these exponent rules will help you for the SAT tomorrow. There's usually at least one problem related to simplifying exponential expressions. So that's why I wanted to also get this in today for you juniors. Here's a different rule. I've got a power outside a parenthesis. If I write this out, this says take x squared times x squared times x squared. How many x's do I have then? X times x times x times x times x times x is x to the 6th. How do I go from this to x to the 6th? What's the rule? What am I doing with my powers? How do I go from 2 and 3? Yeah, I'm multiplying. N times m this time. Multiply. So add, subtract, multiply. You've got 3 rules that could get jumbled up in your brain. So write it out for yourself to double check the rule if you're not really good with memorizing rules. Because you could really figure this out just by writing it out longhand. And then there's something called the distributive power. It just means if there's something outside a parenthesis, you have to distribute it to everything inside the parenthesis when it's multiplication. So these two things are being multiplied together. So I have a to the n, b to the n. Same thing on this one. This is one that people miss a lot. You have to do 3 squared, and then it would be x to what power? If this is a 3 and this is a 2, x to the 6th. So my best answer would be 9x to the 6th, and a lot of people write 3x to the 6th. And then you have to do the same thing for quotients, a to the n over b to the n. What would this last one be if I distributed the 3? X to the 6th over y to the 12th. These are the big rules. So we're going to spend a little bit of time doing practice on this. I think the back page, they're just 2 smaller rules. Yeah, the negative exponent rule you already know because we've been talking about it a lot. It takes the reciprocal of the term and makes the exponent positive. And so why is that? Well, if you just simplified this using repeated multiplication, a over a, how many of them cancel? 3, right? So you're left with 1 over a on the bottom. I just did repeated multiplication. What if I try my rule? What was my rule for the quotient rule on the front page? What do I do with the 3 and the 4? Yeah, you subtract, right? We said that if you have 2 things over each other, you subtract. So I'm taking a to the 3 minus 4 power. So didn't I just prove that 1 over a and a to the negative 1st power are equivalent? I took the same problem and I just solved it 2 different ways. That wasn't a proof formally, but I'm trying to justify that, yes, those are congruent. So how would I write the next example? 45 to the negative first is how much? 1 over 45. And x to the negative second, 1 over x squared. So that's the negative exponent rule. And then the last one on this page is the 0 exponent rule. Anything to the 0 power is 1. And why is that? So let's do it 2 different ways. If you do it repeated multiplication, what do you get? You get 1, because anything divided by itself is 1. You don't get 0. A divided by A is 1. 8 divided by 8 is 1. And 3 minus 3 gives you A to the 0 power, and we just proved that A to the 0 power is 1 by canceling. So that's why it has to be the 0 power, because when you divide the same amount of things on top and bottom, you get 1. So when I subtract 3 minus 3, that property has to match what I got up here. So there is logic behind it. So 12 to the 0 power is 1, and then that parenthesis to the 0 power is 1. I don't even care what's inside of it. So I hope that that refreshed your exponent rules enough to try this page. So I'd like you to try this page first, 304, and you're also going to have to do 300 number 2. And I'm going to check those 2 off. So if you'd rather do the regression part in class, go back to 300 number 2, and you want to save this for homework, that's fine. If you want to do it in the other order,